Hello everyone, my name is Athar Chauhan. Today I'll be walking you through section A of our internal test 3, a set of 20 MCQs from data science. Instead of just giving you answers, I'll quickly explain the logic behind each concept in a simple and very understandable way. For better understanding, we have not arranged the questions serial number wise, we have arranged them in topic wise. So let's begin. I'll just quickly walk you through how we'll cover this whole video. So in this video, we'll go through all 20 MCQs from section a quick explanation behind each correct answer, and the key idea or concept that the question is testing. My goal is to keep this simple, clear, and easy to remember. So let's start with question number 1 and question number 3. Understanding data characteristics. So, question number 1. The correct answer is numerical. Quantitative data. Why? Because quantitative data always represents numbers, things we can measure or count, like age, marks, temperature, or salary. For question number 3, based on standard deviation, the right answer is spread from mean. Standard deviation basically tells us how far data points move away from the average. If it's small, values are close. If it's large, they are scattered. As simple as that. Let's move on question number 2, 8, and 17. Based on statistical measures. Question number 2 is based on Bayes theorem. The right answer for this question is which is seeking for the formula of Bayes theorem basically. So P probability of A by B equals to probability of B by A multiplied by probability of A whole divided by probability of B. So it helps us update our beliefs based on new information, just conditional probability made smarter. For question number 8, RMSE. The correct answer is square root of MSE. RMSE just tells us how far our predictions are from real values. Lower RMSE means it's a better model. Question number 17, R2 square. So correct answer is proportion of variance explained. It explains how much of output your regression model is able to predict. More the R2 value, the better is the fit. Let's talk with question number 4 and 5, data prep and simulation. For question number 4, the question was based on outlier detection and the right answer is sanity check. Outliers can mess up calculations and models, so detecting them is like a basic health check for your data set. Question number 5 was based on Monte Carlo sampling. The right answer is higher dimension plus random outputs. Sorry, higher dimensions plus random inputs. Monte Carlo uses random sampling to solve complex problems, especially great when dimensions are high. Let's move further, talking about question number 6 and 7. Question number 6 seek us through no free lunch theorem. The right answer for this question was no single algorithm is best for all problems. This simply means you can't rely on one algorithm for everything. Choose based on the problem. For question number 7, the right answer was no outputs, find relationships. In unsupervised learning, the machine finds patterns from unlabeled data. No answers are provided, it discovers them itself. Let's move on to our next slide. Question number 9, 11, and 12. Based on algorithm insights. Question number 9, based on linear regression, the right answer was distances, means least squares. The algorithm tries to draw a line that minimizes the square distance between actual and predicted values. Question number 11 was based on k nearest neighbor. The right answer was k closest point. KNN predicts based on what the nearest neighbors are doing. It's like asking the opinion of your closest friend. Question number 12 was based on SVM. The right answer was hyperplane. SVM tries to draw the best boundary, the hyperplane that separates classes with maximum margin. To our next slide, based on advanced concept. The question 10 was based on KL divergence. The right answer was probability distribution. K1 divergence measures how one probability distribution differs from another. Models use it to compare predictions. Next question, question number 13. Based on GAN, the right answer was generative adversarial network. The two neural network compete. One generates fake data, the other detects fake. Together they create realistic outputs. Next question, bagging. The right answer was bootstrap subsampling. Bagging trains multiple models on randomly sampled subsets and then combines them, reducing overfitting. To our next topic wise section, based on tools and technologies. Question number 14, based on Hive, the right answer was SQL like queries on Hadoop. Hive makes it easy to query large data sets stored in Hadoop. Question number 15 was based on Python sets. The right answer was unique elements. A set store only unique items, no duplicates, for fast lookups. Question number 16 was based on TensorFlow. The right answer was multi-dimensional array. Everything in TensorFlow is a tensor, basically an n-dimensional array. Question number 19 was based on Flink. The right answer was stream processing. Flink is designed for fast real-time stream data processing. The last question was based on heap queue. The right answer was priority queue. Heap queue manages elements based on priority, useful for tasks like scheduling. So we'll just wrap up this section A of third internal test, which was set C. Set C was allotted to me. So to wrap up, quantitative data is always numeric. Bias gives us an updated probabilities. Standard deviation measures data spread. SVM uses hyperplanes. GANs generate new data. Bagging builds multiple models from sample data. Flink handles real-time streams. And HeapQ helps us build priority queues. These concepts form the foundation of data science, and mastering them will help in both exams and real-world application.